Next week is finals week. This is the last week of instruction. We meet today to finish the notes for your homework and start the review. On Thursday, we finish the review. And next week, we don't meet for class. I don't plan to have office hour, but I'll be available. So if you want to make an appointment with me, we can meet during our usual class time or during my usual office hour. Okay, so back to the beginning. You have homework due tonight. It's the last homework assignment. The final will be available this Friday at 6 in the morning, due the following Friday, which is the last day of the semester. Okay, after the 17th, that's the end of the semester. We move on to winter break. I get your final grades posted, and then soon they'll show up in your student center. So you can work on past homework or past quizzes or past tests up until the 17th. And then the gradebook is closed in a sense. If you missed any assignments, just write to me and I can give you more time this week and next week to get them done. And the last note is just that we have class today and Thursday this week. No meetings on Zoom next week, but I'm available if you would like to meet with me. Just let me know. So for just a bit, I'll explain some of the setup of the final. But excuse me. It's kind of like your previous exams, and when we get to the review, I'll probably go over this stuff again. So there's 10 questions. This one is cumulative though. Each question is an essay response. You don't have to show work, but it really helps to get more points if there's a mistake made, if I can see where this mistake was. And there's no time limit. There's unlimited attempts. And I think that's it. Okay. I guess the last thing is if you do multiple attempts on your test, I'll give you the highest score. Okay, so starting with homework 12, finishing the notes. Okay, so logarithms, or sometimes called logs, has a setup and then two things that are equivalent to each other. We want to practice using them. So setting it up, we've got a real number b is positive. B is greater than 0. B does not equal 1. And another value, which is a variable, these are your inputs, x. Those inputs must be greater than 0, must be positive values. So we start with log base b. Then you input your x value, which is called the argument. And then you get some value out. So this is a function. It's the, I'm to say it's the inverse function for that exponential function. So if you have this, it is equivalent to, draw a double-sided arrow to represent that. B, the base, to this power y is equal to the argument x. Okay, so you guys take the base, put it to what this whole log is equal to, as its power. This value is equal to the argument x. The top is called log form, and the bottom is called exponential form. Started doing this last time, but I want to practice a little more, going from exponential form to log form. So you may have a way to practice or translate. This is how I think through it. I have this value here with a base 5 and an exponent 3. Base 5 is b, my log base. Log base 5. Like log subscript 5, and then in the argument, it's what the base and exponent would be set equal to, the 125. And we have the exponent here on the other side of the log. Working from log form to exponential form is easier for me. You take the base 5, put it with an exponent 3, equal to the argument. Okay, next one. Is 0.01 equal to 10 to the negative 2 is equivalent to, where you've got the base 10, exponent negative 2. So I want log base 10. Equal to, I would put the 10 with an exponent, and that exponent is negative 2. So leave this on the other side of the log. And that's my argument, 0.01 inside the parentheses. Again, usually once I've written this down, I double check it and go backwards because I have an easier time this way. Taking the base, put it to that as its power, which I have at the top, equal to the argument. So we're going to switch to going from log form to exponential form, which, like I've been mentioning, is kind of easier once you practice. Starting with log base 2 of 8 is equal to 3. Take the base, put it to a power of 3, and set all of that equal to the argument 8. Two to the power of 3, then that is equal to 8. Next is to have the log with the base of 7. And the argument is 49, and then this is equal to 2. Okay, putting this in exponential form, you take the base, raise it to the power of 2. That's all equal to the argument 49. And log base 3 of 1 over 81 is equal to negative 4. Base 3, negative 4. Equal to 1 over 81. Last one, part D. It's log base 10. And this of 0.001 equal to -3. Okay, base 10, raise it to a power of -3. That equal to 0.001. Okay, now there's 4 examples where we're going to solve problems that have logs in them. And then we're going to start to review for the final exam. So here is log base 5 of x. So just to start, I'm going to copy down the problem and then put it into exponential form. So you want 5 with the power 2 equal to x. Which means x is going to be 25. Okay, next. There's log base 2 of -16 equal to x. Let's copy this down, then switch to exponential form. We're going to take the base 2, put it to a power of x, and instead of equal to -16. Okay. So I want to use this result from exponents being unique. So I want to have a 2 to some power on this side. Let me make sure I have this. Oh, here's a problem. Okay, there's two things to talk about. First, I could see right away that the value inside of the log, the input in a sense, is a negative number. Any value that you're putting into the log needs to be positive, like we mentioned at the beginning of the notes. So it's called the argument of the log, this value in the parentheses. And also I was thinking like this negative sign is tricky because you can't really raise 2 to some power and then all of a sudden have it a negative number. So there's no x value there's no solution really. So there's no x value in which you have the log of any base or any base that's positive and not equal to 1. And then argument being negative. So log has a base of 8. The argument is 4. And it's equal to x. Okay, I'm just going to copy this down and then switch to exponential form. You take the base 8, raise it to a power of x, and it's all equal to 4. So if we factor 8 down to prime factors, it's 2 cubed. With 2 cubed in its power. And then factor 4, which is 2 squared. Next, we have 2 with the power raised to another power. So you multiply the powers together and have 2 with the power of 3 times x. So the matching base is 2. And it means that exponents must be equal to each other. This 3x is equal to that too. Okay, then solve for x by dividing each side by 3. And the last one for homework. solve for x. With log base 9 of 1/3 equal to x. So just copy down this problem and then convert to log exponential form. Take base 9, raise it to the power of x, set that equal to 1/3. Okay. So my goal is to have the same base on both sides if I can. And then if that's possible, the exponents must be equal to each other. And then we can use that result to solve for that exponent right there. Let's factor 9. And then what I'm going to do is bring that 3 out of the denominator and write it as 3 with the power of -1. Okay, on this side, you have 3 to the power of 2 times x. Okay, cool. I've got a base of 3, which means those exponents must be equal to each other. 2x equal to -1. Okay, and then divide both sides by 2, so x is equal to -1/2. So that's the end of the notes for homework 12. Now we're going to start to review for the final exam. So I made the test using your homework assignments, picking a problem from most assignments. Kind of skipped, I think, homework 1 and maybe the homework about graphing inequalities. And then after making the test, I picked examples related to each problem. So we'll go through as many as we can. Okay, so I'll pause for a moment though. If you have any questions about homework 12 or any concerns, let me know. Otherwise, we're going to just start doing practice for your last test. Start with finding X and Y intercepts for the following equation. We just find X and Y intercepts. It's this is 10x plus 5y equal to 20. Okay, to get the x-intercept, you let y equal 0. Use your equation, 10x plus 5 times 0 equal to 20. So this is 0, and you have 10x equal to 20. Each side of 10 x is equal to 2. Okay. And then you take that x with that y to create 1 point. And we're going to get 2 points, an x-intercept and a y-intercept. So x-intercept is 2, 0. Okay, to get a y-intercept, you let x equal 0. Okay, 10 times 0 plus 5y equal to 20. Okay, then this is 0 plus 5y equals 20. You get y equal to 4. Okay, then you put that y value with this x value in order, x, y, 0, 4. So your x-intercept is 2, 0, y-intercept is 0, 4. 2 separate points. The one where we find the intercepts, x and y intercepts. X and y intercepts of y equal to negative 3x plus 9. So for your scratch work, let's start with an x-intercept. So let's put y equal to 0. So if I have 0 on that side, it's equal to negative 3x plus 9. And then solve for x. You could add 3x to each side. And then divide both sides by 3. X equal to 3. And then take this x value with the y value that you chose, 0, and write them in order, x, y, 3, 0. Okay, then we look for the y-intercept. At that point, you need to let x equal 0. Right. Okay, this would be 0, and y is equal to 9. When we put them in order, x, y. X is 0, y is 9. Okay. And then on to a new kind of homework problem. We start to find the equation of the line. So I suggest using y equals mx plus b, where m is the slope. This line goes through the point 2, 3, and the point 0, negative 5. Alrighty, so I like to use y equals mx plus b. You don't have to, it's just a suggestion. M is the slope. So first find m. Okay, it's rise over run. So you take a difference in y values, divide by a difference in x values. Like y1 minus y2 over x1 minus x2. Then plug in values from your points. We're going to call this x1. This is 1. The x2. Okay, so in the numerator, we have 3 minus -5. It's over 2 minus 0. So in the numerator, we've got 8, and then divide that by 2. So we're just trying to finish this slope and the y-intercept, the value for m and the value for b. M equals 4. We'll pick either point to figure out what that b value is. I like to pick the point that has 0 in it, but either one will get to that. Correct y-intercept. We'll choose this point. Y is -5 on this side. Plug in x equal to 0. And then add b. -5 is equal to 0 plus b. -5 is equal to b. All right, final answer is y equals 4x plus -5, or y equals 4x minus 5. Okay, another example where we find the equation of a line that goes through 2 points. Okay, this time we're going through the point -2, 2, and the other point is 4, 5. I would like to use y equals mx plus b. and you find m and find b. M is the slope. You could do y2 minus y1 over x2 minus x1, or we could do the same thing as before. Y1 subtract y2. You match up the subscript. x1 is x. Okay, so it doesn't matter which point is which, just like how it matters. It doesn't matter if you have the subscripts here reversed. X1 and okay, I'm going to take 2 and subtract 5. And it's divided by -2 minus 4. So it's -3 or -6. Should be a positive. Okay, so we've gotten the m value. M is 1/2. Okay, and then pick either point. I'm going to pick this point. It doesn't matter which one. We just need x and y from one of the points. Okay, 5 is going to go over here. And it's equal to 1/2 times 4 for x. Okay, 1/2 times 4 is 2. And b is going to be equal to 3. Okay, I'll put this in right there. So positive 1/2 x, add b is 3. Okay, and then move on to the next problem, exponents. So simplify and then write with positive exponents. Yeah, 4 times x to the power of -2. This has a power of 3. It's all over x power of -3. Okay, first I'm just going to copy down the problem. Starting with 4. Multiplied by x, so -2, -3. -2, then the power of 3, divided by x with power. Okay. Let's take care of this part. -2 power raised to a power of 3 is going to be -2 times 3, 4, and x has the power of -6. Okay. There's different options. I could bring this into the denominator, just the x with power -6. So it would be x to the power +6. But the 4 would stay in the numerator. Okay, and now you would add those exponents together at the base of x. So 4 over x to the power of 3. And then that's fully simplified. And we've written it with positive exponents. Okay, one more like this where we simplify and write our answer with positive exponents. This time it's a to power -4. B has power 5. These are multiplied together. A to the -4th times b to the 5th times a cubed times b. And that has a power of -2. Let's just copy down the problem. It's a to the -4. B a cubed b 2 outside. All right, I'm going to start here with this power of -2 on a cubed times b. So you need a cubed with power -2, and b also has power -2. So when you have that power to that power, they'll multiply together to be -6. And then here b is the power of 1 times -2. So when everything's multiplied together, we can first look at multiplying this a with -4th times the a with the -6. So a has a power of -4 plus -6. B has a power of 5 plus -2. Yeah, this is one way to solve the problem. Let's keep going. So a has a power of -10. Power on b would be 3. And then we need to write this with positive exponents. So we'll bring this to the denominator, and then we have b cubed over a with a power of +10. Okay. I think we're moving to something else. If time. Yeah, I think there's time for one more example. We're going to multiply using the distributive property. Okay. So the idea for most of these problems is to expand and then combine like terms if there are like terms, but we won't have that next step. We are just going to take x squared, multiply it with 6 over x squared minus 1 over x plus 5. So you distribute this x squared to all 3 terms and then make sure you keep the same signs. So x squared times 6 over x. Minus x squared times 1 over x. Plus x squared times 5. Here, I think it helps to put x squared over 1. And you can kind of see it better that the x squared over x squared is going to reduce to 1 and left to 6. Or you could use exponent rules. X would have a power of 2 times 2, which would be x to the 0, and x to the 0 is 1. Anyway, this first term is 6. Subtract the second term, which is x to a power of 2 minus 1. And you have 5x squared. You add x. Okay, we're going to do one more. We're just going to multiply. One fifth times 25x minus 10. Okay, so you take the number out front, the whole value or the fraction, 1/5. Distribute it, so multiply it with the first term and the second term, and keep that sign. So 1/5 times 25x. Subtract 1/5 times 10. 25 divided by 5 is 5 times x. and then subtract 2. Which is 10 divided by 5. Okay, so we have more examples, but we've run out of time. We're going to meet on Thursday to finish working on problems to help you with your final exam. And let's see, I have office hour Wednesday and Friday. Actually, not this Wednesday. I have office hour this Friday. Okay, that should be it. We'll see you on Thursday. Thank you for coming to class.